So similar to the imperial unit table that we had before, here's our metric unit table with respect to length measurement only, because we are only talking about meters. We can talk about some reference. So a reference, something I can refer to that is going to be about a millimeter thick. This is what a good reference for a millimeter thick would be about the thickness of your fingernail. Oops. So the thickness of your fingernail is about a millimeter thick. A centimeter, referent for a centimeter would be the width of a finger. Width of a finger. Sorry, I had a message on my screen there. Width. I wouldn't say that your thumb would be a good one, because your thumb's probably a little bit wider than a centimeter. But the width of, well, for me it's a centimeter. For some of you with bigger hands, it might be maybe your pinky finger. But that's a good reference. And then something that hopefully you know is that 1 centimeter is 10 millimeters. A few others that I hope you also know: 1 meter is 100 centimeters. Well, if that being said, and 1 centimeter is 10 millimeters, then 1 meter is 1,000 millimeters. That one maybe not known so well, but again, another one that you should know is 1 kilometer is 1,000 meters. Okay, so a few things that you should know there. A meter, a good reference for a meter would be the same reference as for a yard, because the difference between a yard or a meter are like about 3 inches or something. So again, arm span, remembering that goes from your chest to your fingertip. Okay. And then a kilometer, again, this time a kilometer would be about 2.5 laps of the track. Be significantly less than 20 minutes, so approximately a 10-minute walk maybe. Okay, so just a few reference for a few different things there for the metric system. Now, converting between units in the metric system, sometimes a little bit easier, sometimes not, but the good thing is it's all based on the number 10. So you're multiplying or dividing by tens or hundreds or thousands, which makes the calculations a little bit simpler. A few different shortcuts that you may remember on just moving decimal places, depending if you're going from smaller to bigger or bigger to smaller. I try not to show shortcuts. I like to show the math behind it all, so that you can understand it. And then if you can come up with shortcuts after that, then that would be your choice. Okay, so example, convert 50 meters to centimeters. So first thing I need to do is look at my table and realize that, well, I have a conversion factor that relates meters and centimeters. For every 1 meter, there are 100 centimeters. So I have to use that somewhere. So using conversion factors, I start with my 50 meters, and I'm going to multiply by some conversion factor that relates meters and centimeters, making sure that my meters is on the bottom, my centimeters is on the top, so that my meters will cancel out. I know that 1 meter is 100 centimeters. Meters will cancel out. Multiply across the top gives me 5,000. Across the bottom just gives me a 1. I don't have to write it. I'm left with centimeters. Okay. Using proportions, you can also look at this and say, well, if I'm converting 50 meters to centimeters, x centimeters, so make a ratio, 50 meters to how many centimeters? I make that equal to my same conversion factor of 1 meter is 100 centimeters, this time making sure that my units stay on the same part of the fraction. So that's equal to 1 meter over 100 centimeters, and then I simply cross multiply and divide. 50 times 100, divide by 1. So 50 times 100 divided by 1. My units will cancel. I'm left with 5,000 centimeters. Same place. Now, difference between using conversion factors and proportional reasoning. Conversion factors you'll see again and again and again in other courses, chemistry, physics, again later in some upper level maths. Proportional calculations is a shortcut, It is a bit of a cheater's way to get around how to calculate. I personally don't care which one you use, as long as you make sure that you're being consistent. Okay, if you are planning on taking some of those chemistries or physics classes coming later, or doing pre-calculus 11, strongly recommend and suggest that you figure out and understand conversion analysis, using conversion factors, because that will help you out later. Proportional reasoning, like the purple one, number 2 below, will probably actually confuse you a little bit if you try to use that later. Okay. So let's finish off this example. Example B, we want to convert those same 50 meters to kilometers. So we're converting 50 meters still. I know that for every 1 kilometer there are 1,000 meters. So I take my 50 meters. Oops, I don't need a small zero. I'm going to take my 50 meters. I'm going to multiply by my conversion factor such that my units will cancel. So I want my meters in the bottom. Meters in the bottom, kilometers on the top. That gives me 1 over 1,000. And in this case, my meters will cancel. I'm left with kilometers, which is 50 over 1,000, or 0.05 kilometers. Okay. Again, using proportional reasoning, let's take my 50 meters. I'm converting to X number of kilometers. If I make that equal to a factor, that is 1,000 meters over 1 kilometer, cross multiply, divide, 50 times 1 divided by 1,000, 50 times 1 divided by 1,000. You can see we're doing the same calculation. Gives me 0.05 kilometers. Get to exactly the same place. All right, so here's some questions, and like the rant that I've probably already given you during the first day of class, the only way you can get better at knowing how to work with this stuff and understand the questions, be able to work through them, is to practice.